6.5, page 281, 1 through 20. Number 1, data set 1 body data in Appendix B includes the heights of 147 randomly selected women, and heights of women are normally distributed. If you were to construct a histogram of the 147 heights of women in data set 1, what shape do you expect the histogram to have? 1, I would expect the histogram to be approximately bell-shaped. If you were to construct a normal quartile plot of these same heights, what pattern would you expect to see in the graph? They should be in an approximate straight line path, pattern, whatever you want to call it. Number 2, after constructing a histogram of the ages of 147 women included in data set 1 body data in Appendix B, you see that the histogram is far from being bell-shaped. What do you now know about the pattern of points in the normal quartile plot? Let's see, either they are not reasonably close to a straight line pattern, or there is some systematic pattern that is not a straight line pattern. Okay, and this is like a very straight line. What if, let me see here. What if you had see, that might be kind of straight. But what if they did something like this? See, what if they did something like this? this might be normal, and this here, this kind of has a systematic pattern that is not normal. Not normal. And another one that you see fairly regular might look something like this right here. Okay, that wouldn't be normal either. Number 3, small sample. Data set 29, coin weights in Appendix B, includes weights of $21 coins. Given that the sample size is less than 30, what requirements must be met in order to treat the sample mean as a value from a normally distributed population? Well, we must verify that the sample is from a population having a normal distribution. Identify 3 tools for verifying that requirement. Histogram, IDing the number of outliers, and constructing a normal quartile quantile plot. Number 4, assessing normality. The accompanying histogram is constructed from a diastolic blood pressure measurements of the 147 women included in data set 1, body data, in Appendix B. If you plan to conduct further statistical tests and there is a loose requirement of a normally distributed population, what do you conclude about the population distribution based on this histogram? Well, looking at it, it's roughly bell-shaped, so I'd conclude that the data are from a population having a normal distribution. So I would say it's roughly bell-shaped and normal distribution. Number 5, Ages of presidents. It says on these, the normal quantile plot represents ages of presidents of the United States at the time of their inauguration. The data are from data set 15, Presidents, in Appendix B. So in exercises 5 through 8, examine the normal quartile plot and determine whether the sample data appear to be from a population with a normal distribution. So I am looking at number 5, and I am not seeing any systematic pattern, and it is roughly following a straight line. So I'm going to say number 5 is normal. Let's take a look at number 6, Diet Pepsi. The normal quartile plot represents weights, pounds of the contents of cans of Diet Pepsi from data set 26, cola weights. In Appendix B. And with number 6, I think I'm going to go again with normal. They're reasonably close to a straight line pattern, and there's no other pattern that is not a straight line pattern. So I'm going to go with normal again. Both 5 and 6 are reasonably close to a straight line pattern. What about number 7? Now I am seeing that one. Those they do something that's kind of like that right there. So I'm going to say not normal. In number 8 looks more like this right here. And again, I'm going to say that is not normal. All right, that's not a normal distribution. All right, number 9. Let's look at number 9. Now, we're going to do 9 and 13 together. In exercises 9 through 12, refer to the indicated sample and determine whether they appear to be from a population with a normal distribution. Assume that this requirement is loose in the sense that the population distribution need not be exactly normal, but it must be a distribution that is roughly bell-shaped. So number 9, and let's see, you can find that data, number 9, on page 577. Page 577 and 22, 22, 22, 26, 24, and 23. That's your. Now, it's really hard to tell with just 5. It really is. Let's go to our calculator. And I've already put, let's see here. Chocolate chip cookies, I got 13, 24, 16, 21. That's not the same numbers. Which numbers do I have? Oh, 13, 24, 18, 16. Reduced fat, I got the right ones here. I put the wrong ones on here. I put the wrong ones there. I should have put 13, 24, 18, 16, and 21. Now, like I said, you got 5 numbers there. So to do a histogram, here, on, graph, and then we want just chocolate chip. And then there you go. Menu, 2, 1, 1, 3, and it looks like that. And it's really hard to tell because you only got 5 numbers, and that looks like fairly straight. You'd have to play with the histogram to see what you could do with it. What we might do is go menu, 1, and then 4. Well, let's take a look at this. Now, these are reasonably straight lined. Okay, I'm not really seeing a systematic pattern. I got 1 on, 1 on. That's still on, that's still on, and that's still on. So I'm going to say for number 9 and number 13, this is 9 and 13, I'm going to say normal. Normal. Okay. What about 10 and 14? 10 and 14. Ages of best actresses. What page is that on? Ages of best actresses. Ages of best actresses. And I believe that's on page 572. Oscars, yeah, page 572. And we got 22, 37, 28, 63, and 32. This time, let's try this in, the 84. Let's kick that up. Here it comes. There's a little bit of difference between the 84 and the Inspire. We're going to start off by pressing Stat and 1, and in L1 we're going to put 22, 37, 28, 63, and 32. All right, that's what we do first. Make sure you. Now let's go to second, y equals, and that gives us stat plot. We're going to choose number 1, and we're going to turn it on. So we turn. Now we want to make sure that we highlight the one all the way over here to the right. That's the one we want to highlight. And our data list is in L1. But if you wanted to change it, you would press second and then stat, and then you could choose whichever one you got. So let's choose, we're going to choose 1. Data axis should be X. All right, we got all of that. So now we're going to press zoom, and then 9 for zoom stat. And there we go. Yeah, that's not too bad. So you could probably draw a line. That wouldn't, that might be your line. It might not. But anyway, so there we go. We're going to say this one is normal. Like I said, it's kind of hard to do with just 2. But if we go back to the Inspire, there's the actresses. On, graph, actresses. This is one of the reasons why I like the Inspire. It does a better job. And then menu, 1, 4, and you can see what I'm talking about. Well, my line wasn't too bad, I don't guess. All right, so there we go. So we went with normal on 10 and 14, 11 and 15. It says the weight pounds of discarded yard waste listed in data set 31. So I think that's going to be on page 578. And yard 0.38. 0.24, 0.63, and 0.15. Just looking at those numbers, again, it's really hard to tell. Looking at these, it was hard to tell. Those, they're not too, there's a little bit of difference here. Notice, you got 0 to 0. There's a lot of difference there. All right, so let's just take a look. We'll go back to the Inspire. And yes, I've already put them in there. On graph, garbage, menu, 1, 4. Now, what are we thinking about this? Number 11. 11 and 15. What do we think? Are we seeing a pattern? I'm kind of seeing a pattern here. It goes and then down. So I'm going to say not normal. And let's go back. See, I'm seeing it systematically. But again, you've only got 5 numbers. If you looked here, 16, that's not really a pattern there. And then there, not really a pattern there. So there we go. Not normal. A little bit of a pattern. And if you plotted all of them, you would see that just gave you a few of them. What about 12 and 16? What about 12 and 16? Diet Coke. The weight pound of contents in cans of Diet Coke as listed in data set 26. Let's try the 84 again. Show you one more time how to do it. Okay, so we're going to go to Stat, and then 1, and we're going to edit those. So first, that came from dataset 26, and that's on page 576. And Diet Coke, well, what are we looking at? We're looking at the weight, okay, the weight of Diet Coke. So let's go back here. And we got 0.7773. 0.7773, enter. And we got 0.7758. When I run both of these calculators, it really slows stuff down. and 0.7896, 0.7868, and 0.7844. All right, second stat plot. It's actually already set up because we set it up a second ago, but you want on, you want all the way over here, you want your list, you want X, and then zoom 9, and there it goes. And again, that one is a fairly straight pattern, isn't it? Let's see here. Let's see what we can do. That one's kind of hard to hit, isn't it? So what do you think about that? I'm not thinking that's normal. Let's see what we, one below, one above, two below, one above. I think I'm going to go with normal. I'm going to go with normal. I'm going to go with normal. I did not see a pattern. It wasn't super straight, but it was reasonably close. All right, what I want, let's see here. We got number 17. 17, 18, 19, and 20. We'll let you do those and put those on the form. I hope you're staying safe and having a good day.